Every time you turn a key or press a button, a controlled series of explosions begins happening hundreds of times per minute inside your car. These tiny explosions generate enough force to move 2 tons of metal at highway speeds. But how does burning fuel actually turn into motion? The most common car engine today is the 4-stroke internal combustion engine. Unlike a jet engine, which runs on continuous combustion, a car engine works through 4 distinct strokes: intake, compression, combustion, and exhaust, repeating hundreds of times every minute inside each cylinder. A typical engine contains 4 to 8 cylinders machined into an engine block. Inside each cylinder sits a piston, connected via a connecting rod to the crankshaft, which converts the piston's up and down motion into rotation that turns your wheels. The cylinder head above contains intake and exhaust valves, fuel injectors, and spark plugs, all timed by the camshaft. Stroke 1, intake. The piston moves downward, the intake valve opens, and a fuel-air mixture is drawn in. Modern engines inject fuel directly at pressures up to 200 bar. Stroke 2, compression. The valve closes and the piston moves upward, compressing the mixture to 1/10 its original volume at a ratio of around 10 to 1, making it highly combustible. Stroke 3, combustion. The spark plug fires just before the piston reaches the top. Temperatures reach 2,500 degrees Celsius, generating cylinder pressures of 50 to 100 bar, forcing the piston down with tremendous force. This is the power stroke. Stroke 4, exhaust. The exhaust valve opens and the piston pushes burnt gases out through the catalytic converter, which transforms harmful pollutants before they exit the tailpipe. Each power stroke rotates the crankshaft through the connecting rod. This torque travels through the flywheel, gearbox, and driveshaft to your wheels. A typical family car produces 100 to 150 horsepower, while performance engines exceed 500 horsepower from this same basic principle. 2 systems keep the engine alive. The cooling system circulates coolant through the engine block, dissipating heat through the radiator. The lubrication system pumps oil under pressure to every moving surface, preventing metal contact between components, moving at thousands of revolutions per minute. At 3,000 revolutions per minute, a 4-cylinder engine completes 6,000 precisely timed power strokes every minute, each requiring perfectly coordinated valve timing, fuel injection, and ignition within fractions of a millisecond, all managed automatically by the engine control unit computer. Modern engines achieve 40% thermal efficiency, improving further with turbocharging, variable valve timing, and hybrid technology.